Continuation of lectures on functions of a real variable. This is the 6th lecture in this series. The title is Graphs of Functions. I am your lecturer, Professor E.O. Efanga. Definition. The graph of a function y equal to f of x is a set of connected points xy in the xy plane. Given the range of values of x, the corresponding values of y can be determined. These are often displayed in a table called table of values. Once the table of values is constructed, the point xy are then plotted and connected by smooth curve to obtain the graph of the function y equal to f of x. Example 1. Let us draw the graph of the function y equal to 4x plus 3 for values of x ranging from minus 3 to plus 3. Solution. First, we have to construct table of values for this graph, and the range of values of x is given to be from minus 3 to plus 3. So the table of values is as follows. This is a table consisting of 2 rows. The first row is for x values, while the second row is for y values. So the x values are minus 3, minus 2, minus 1, 0, 1, 2, and 3. Let us now find the corresponding values of y for a given value of x. When x is minus 3, y will be equal to 4 times minus 3 plus 3, and that will give us minus 9. When x is minus 2, y is equal to 4 times minus 2 plus 3, and that is equal to minus 5. When x is minus 1, y is 4 times minus 1 plus 3, and that gives us minus 1. When x is 0, y is 4 times 0 plus 3, which is equal to 3. When x is 1, y is 4 times 1 plus 3, and that is 7. When x is 2, y is 4 times 2 plus 3, and that gives us 11. And when x is 3, y is 4 times 3 plus 3, which is equal to 15. Having obtained table of values for this graph, we can then plot the graph of y on the vertical axis and x on the horizontal axis. So the graph is as shown here. It's a straight line graph. So this straight line is the graph of y equal to 4x plus 3. Example 2. Draw the graph of the function y equals to 2x squared minus 3x plus 5 for values of x ranging from minus 3 to plus 3. Solution. Again, we construct table of values as follows. The values of x ranges from minus 3 to plus 3, and these are the corresponding values for y. When x is minus 3, y is 2 times minus 3 squared minus 3 times minus 3 plus 5, and that will give us 32. When x is minus 2, y is 2 times minus 2 squared minus 3 times minus 2 plus 5, and that will give us 19, and so on until you get to when x is 3, y will be equal to 2 times 3 squared minus 3 times 3 plus 5, which is equal to 14. Having constructed the table of values, we can then plot the graph of y equals to 2x squared minus 3x plus 5, and this is the graph. So this graph is called a parabola. Example 3. Draw the graph of the function y equals to x cubed for values of x ranging from minus 3 to plus 3. Solution. Again, first we have to construct the table of values, and here is the table of values for this graph. X ranges from -3 to +3, and these are the corresponding values of y. When x is -3, y is equal to -3 to power 3, and that will give us -27. When x is -2, y is -2 to power 3, and that is -8, and so on. So we can then plot the graph of y equals to x cubed as follows. So this is the graph of y equal to x cubed. Example 4. Draw the graph of the function y equal to the absolute value of x minus 3 for values of x ranging from -3 to +6. Solution. Again, we construct table of values as follows. The values of x ranges from -3 to +6, and these are the corresponding values of y. When x is -3, y is equal to absolute value of -3 minus 3. -3 minus 3 is -6, and the absolute value of -6 is 6. Please, absolute value ignores the negative sign. Whether the sign is negative or positive, absolute value makes it to be positive. When x is -2, what you have here will be -2 minus 3, which is -5, and absolute value of -5 is +5. When x is -1, y is absolute value of -1 minus 3, that's absolute value of -4, and that is +4. When x is 0, y is equal to absolute value of 0 minus 3, which is -3, and absolute value of -3 is 3, and so on. We are now ready to plot the graph of y equal to absolute value of x minus 3, and this is the graph. Example 5. Draw the graph of the function y equal to -2 if x is less than -1, y equal to 2x plus 1 if x is greater than or equals to -1 and less than or equals to 1, y is equal to x squared if x is greater than 1, for values of x ranging from -3 to +4. Solution. Let us construct the table of values as shown here. The range of values of x is from -3 to +4. When x is -3, y is equal to -2. Please note, -3 is in this range. When x is less than -1, the value of y is this constant value -2. So when x is -3, y is -2. When x is -2, which is also in this range, y is still -2. When x is -1, observe that -1 is in this range. So we are using the function y equals to 2x plus 1. So when x is -1, y is equal to 2 times -1 plus 1, and that will give us -1. When x is 0, again 0 is in this range, so we are using y equals to 2x plus 1. So 2 times 0 plus 1 will give us 1. When x is 1, 1 is still in this range. We are still using y equals to 2x plus 1. So that will give us 2 times 1 plus 1, which is equal to 3. When x is 2, 2, observe it, is in this range. You can see that 2 is greater than 1. So we are using y equals to x squared. So when x is 2, y is equal to 2 squared, which is equal to 4. When x is 3, 3 is in this range. So y is equal to 3 squared, which is equal to 9. When x is 4, 4 is still in this range. Y is equal to 4 squared, which is equal to 16. So that is the table of values for this function. We are now ready to plot the graph. So the graph of this function is as shown below. You can see in the range, when x is in the range from -1 to -3 here, our function is a constant function which is equal to -2, y equals to -2. But in the range from -1 to +1, our graph is a straight line graph. That is this line. But when x is greater than 1, our graph is a curve. That is y equals to x squared. This one is the graph of y equals to -2. This is y equals to 2x plus 1, while this one is y equal to x squared. Example 6. Draw the graph of the function y equal to exponent x for values of x ranging from -3 to 6. Solution. First, we construct the table of values as follows. The range of values of x is from -3 to +6. When x is -3, y will be equals to exponent -3. Exponent -3 to one place of decimal is approximately 0. When x is -2, y is equal to exponent -2, and that is approximately equal to 0.1. When x is -1, that will be exponent -1, and that is equal to 0.4. When x is 0, y is exponent 0, which is equal to 1, and so on. So we are now ready to plot the graph of y equal to exponent x, and here is the graph. This green curve is the graph of y equal to exponent x. Example 7. Draw the graph of the function y equal to ln x, which is also written as log x in base e, for values of x ranging from 1 to 10. Solution. We construct table of values as follows. These are the values of x from 1 to 10, and these are the corresponding values of y. When x is 1, log 1 base e is 0. When x is 2, log 2 base e is 0.7. When x is 3, log 3 base e is 1.1, and so on until we get to when x is 10, log 10 base e is 2.3. We are now ready to plot the graph of y equals to ln x, and this is the graph. This curve is the graph of y equals to ln x. On your own, plot the graphs of the following functions for x ranging from -5 to +5. 1. F of x equals to 2x plus 1. 2. F of x equals to 2x squared minus 3x minus 2. 3. F of x equals to 2 plus 3x minus 2x squared. 4. F of x equal to 1 all over x. 5. F of x equal to square root of x. This is the end of lecture 6. Thank you for watching, and keep on watching.